In this video, we are going to discuss about the stability factors. So after completion of the stability factors, the students will be able to study the basic circuits using this diodes and transistors. And the stability factors, so if there we can say that if we are keeping the bias point as stable means, then the skew point will be the best operating point. We can say that the skew point is very stable, but whenever there is a stable also, there will be some changes in the degree of the operating point due to this variation of the temperature. So there are three variables which we can say that is changing in the case of the temperature. So that three stability factors we are defining as S is equal to dou IC divided by dou ICO when VBE is constant, which we call it as beta as constant, or we can say as S is equal to del IC divided by del ICO when VBE beta is constant. And next the stability factor is S dash, which we can write as change in the collector current divided by base emitter voltage when ICO and beta is constant, or we can say it as del IC divided by del VBE of ICO into beta constant. S double dash is nothing but this change in the collector current divided by the temperature which we in which this ICO and VB is constant, or we can write this S double dash is equal to del IC divided by del beta, which is ICO divided by or beta constant. So in the case of the stability factor, we are going to find out the three cases, that is S dash and S double dash. So for a common emitter configuration, we can say that is collector current, which is nothing but the minority current as well as the majority current. So majority current we say it as beta into IB, and the minority current we call it as ICO. So when base, that is emitter, is open circuit means we can write the equation as 1 plus beta into ICO. So when there is changes in the ICO, then the changes in the del ICO, then IB changes by dou IB and IC changes by dou IC. So there will be a change in the temperature, so that we can write the equation. This equation is changed to, and we can differentiate with respect to this IC, so that we get that this dou IC is equal to beta into dou IB plus 1 plus beta into dou into ICBO. If we are differentiating in the case of the IC, then this term becomes 1, so that we get 1 is equal to beta into dou IB divided by dou IC plus 1 plus beta into dou ICBO divided by dou IC. You can take this term to the left hand side, so from that we can find out the value of dou ICBO divided by dou IC, which is nothing but is equal to 1 minus beta of dou IB divided by dou IC divided by 1 beta. And next we are going to find out the value of stability factor for S dash. So S dash, we know that is the equation is S dash is equal to dou IC divided by dou VB, where that ICBO and beta is constant. So from this we get the equation that is IC is equal to beta IB plus beta 1 plus 1 into ICBO. And the stability factor S double dash, so in the case of S double dash, we can write the equation as S equal to dou IC divided by dou beta, which is nothing but VBE of IC is constant. And while you are differentiating this equation, we get that is dou IC is equal to IC by beta. Since we are taking this IB is equal to IC by beta, which is in case IB is very greater than ICBO. So you can substitute in this equation, so that we will be getting dou IC divided by dou beta VCC by RB minus VBE by RB plus ICBO plus IB is equal to beta. And the relationship between the S and S dash, we know that S is equal to 1 plus beta and S dash is equal to IC by beta. We can multiply the numerator and the denominator by the term of 1 plus beta. So this equation becomes S double dash is equal to IC of 1 plus beta divided by beta of 1 plus beta. So you can cancel this term. You will be getting that S double dash is equal to IC into S divided by, since we know that stability factor S is equal to 1 plus beta, so you can substitute this value here. So S double dash is equal to IC into S divided by beta into 1 plus